Maybe or not. So we have 2 more weeks.
Yeah, definitely.
Then we can have a summer vacation, right? So I hope we are not going to meet on summer. Okay, I'm going to teach you the operating system again. But hopefully we will not see again. Okay, so to do that, you guys need to work hard the rest of the semester. And then the best way is try to focus on your best on the rest of the part. Also, if you missed anything regarding to the quiz or the attendance, you cannot restore. Okay? There's no other way. But if you missed still at the end of the semester, when I finalize your grade, some of the students missed the submission. There's no way to give the point. Okay, so please try to your best to make up if you missed anything. Regarding to the midterm, no way to change your grade, but you have still chance to make it better by focusing on your final exam. Okay, and also I'm going to apply the different curve for the for undergraduate and graduate. Also, it depends on the overall performance of the group. Like the group means the undergraduate or graduate group. So it depends. Okay. Any question regarding to the rest of the semester schedule? And for the project, you can keep the same project the group as the project 1. Okay. I'm not going to allow the individual project, but if you have any issue, why don't you contact the GA? Okay. And we will have the final exam on May 7, Tuesday, 1:30, 5:45, Thursday, Thursday, 1:35. So anyway, 1:35 or 45, the 2-hour exam, but not this room. I found the bigger room, Dana Hall 107. Okay, it's the same time but different room. So do not come to this room for your final exam. So plenty of space. So in the Dana Hall. Okay, so don't worry about too much somebody cheating your exam. Okay, any question? Probably we will have a chance before semester ends to quickly review the second part of the semester. If I finish to make the final exam question, probably will be helpful. Otherwise, it will be general review of the second part. Okay. One. So any questions? So we will continue the chapter 11. Hopefully, I try to a little bit speed up to cover the additional part of the operating system. That means the virtual machine, but I'm not sure whether I can cover or not. It's very hot. So I need the heater. So AC is coming? I don't think so, because I was in a hurry. I had an interview with the new faculty. Hopefully, we will hire the new faculty, then this course will be taught by the new faculty. Because, as I said, one of the students comment on the, what is that? It's a professorrate.com. My professor. Yeah, something like that. My daughter, she actually checked the website with my name. Then she said one of the students commented it's the worst. So do not take this course. So, because of that, I really disappointed. I'm not going to teach this course. But you know, the new one is not better than old one usually. Okay, anyway, so no way to avoid this course. This is a core course. So also operating system is a really fundamental. So until sometimes you may not realize the importance of the operating system, but when you join the project, when you encounter something, application problem, that one is caused by the operating system problem. So in case you have the problem in the project, you actually ask all the vendor. So customer service center or the vendor, like if you have the problem of the database server, not only just the database guys from the Oracle, whatever, but also you need to ask someone from the operating system, even hardware. Then they get together, then they usually said, it's not my problem. Who need to find that problem? It's you, as the project manager or the project member. What caused the problem? Then you can ask and push them to solve that problem. Operating system is one of the important part of your project. Okay, and even though we are discussing about the traditional, the theoretical algorithm that has been used operating system, but based on that, even though you have the new operating system model or the embedded specialized operating system, you can easily catch up to understand that. Today we are going to continue the discussion on the file system interface. The last time we mainly discussed about the file structure. What is a file? Data structure. Yes. So do not answer the data structure on your final exam sheet. Really, even though I mentioned most of my questions can be answered with the data structure, that doesn't mean you can answer data structure. Okay, data structure what? That is more important. So, but I guarantee some of the students will answer data structure. So I cannot give any credit. So what is the file? It's the data structure for processing. Storage of data, information. You can keep such the data in your file. Okay. Anyway, you need such information for CPU. However, CPU can access the data through the memory. However, the memory itself is a very small, expensive data structure. So instead, you can use the storage, secondary storage with something data structure. Okay, that is the file. And when we have the bunch of the file, we need something special software that is the file system. Okay, so we mainly discuss about the attribute of the file that include the name, identifier, type, and so on. Also operation of the file that can manage the file information. Using such operation, we can create, the write, the read, and so on. Of the file. Okay, so that file should be managed by per process and the entire operating system, because only one process can access and write the data. Okay, so that is exclusive the lock. But if the other process are just read the data in the file, that can be shared lock. To manage the locking mechanism, so we need to keep track of which process are accessing or changing the file. Okay. So these are the example of the Java API to handle that. Okay. So this is a screenshot. I think that I found. So if you want to practice the operating system Windows, there are not much thing you can actually manipulate, but Linux and Windows are different. You can find many examples. It doesn't matter what operating system you use. If you go to the website for the textbook, you can download the Debian, the virtual machine. So it's not very big. Also, you can download the Ubuntu and install and practice by yourself. That's definitely helpful to understand the operating system. Right now, because you learn many of the algorithms used in the operating system, you can understand the meaning and concept of each application. So, for example, I'm not sure you can see. I cannot find how I can make it bigger one, but so as you type the file, for example, what kind of file that we have? So for example, if I type this one, or both of them are directory, so we can see the type of the file that I showed the last class. So let's move one of them. Okay, so file time. So it's a SD Pascal program text. So that means it's a text file, so source file. So you can see the type of the file. They're using such a command. Similarly, Unix and Linux provide a lot of commands that implement the algorithm. Some of the algorithms are used in operating system kernel itself. It's a system program, Unix program. Otherwise, it can be used for the application program, so you can use. Or the benefit of the Linux is they provide the source code. If we want to, you can modify and rebuild the kernel. Then, or if that is not part of the kernel, you can compile and reuse as an application program. Also, another benefit of using the Linux or the Unix system is you can use the script language. Many of the script languages already utilize the system call that we have a lot. So it's kind of API. So you don't have to compile or whatever, just using Perl, Python, even Perl. Perl actually developed by the Unix administrator for his convenience to manage the Unix system, which means you can use the Perl script to even manage or manipulate your operating system. Okay. Why just more? I'm still getting used to the interface of the Windows, not Windows Surface, I think. Okay, so that is a file, and we have seen such a file structure. It is basically ASCII format and the binary format. So for each application, it has their own data structure. You don't have to try to understand all the data structure, but when you develop the application program, you need to store your data in the file format. If you are using your own file format, you need to define your data structure, then create the file, then should be able to read such a file or write the file. So that is a file structure. Basically, it has two access mode. One is a sequential, another one is the random access. The random sequential is easy to understand and also implement. So it's from the beginning to end. But random access, we are going to use the direct access, or the random access, use the pointer. So logical record of the pointer, then we can find directly where the data is located. Then, what if we have the many files? So it's not easy to manage the millions of files, thousands of files, not only because we have the many files, but also some of files are only the data. The other files are for the source code. Sometimes this file is a binary code. So based on that, the contents of the file, we'd like to classify them. So can we do that with the file structure? No. The file is the individual independent file structure. So we are going to, I think the last time that end of the last class, we talked about the directory structure. So directory and the file structure, two structures are the main of the file system. Okay? So file system, when we are talking about the file system consists of such a file structure as well as the directory structure. One more important part is the disk, the format. Okay, format of the how to make the data structure for disk. Okay, so what is the directory? Is a collection of the not all the file information, only header information. Okay, so that is the this is the directory structure. Okay, so this, and also in addition to the disk, the directory structure, another important part of the file system is the disk structure. There are two types of the disk structure. One is the raw device. We need to have the file system to store the data on your hard disk drive? Must? It's mandatory? No. We don't have to. You can keep the data directly in your hard disk drive without the file system. That is called as a low device. So your low device has the for example, we are using the CD-ROM drive, the magnetic hard disk drive to have the sector number like this. So if we know the address of this one, then we can directly store the data over here. Okay? That is called the low device. Otherwise, we can use the file system software that can actually understand this one, then format it by the block or the relative, the address. So that is the based on your volume of that. What is the benefit of the using the low device? It's a storage what? It's a fast. So some of the application, such as the database system, utilize such a low device. At that time, you don't have to use the file system. If you are using the file system anyway, you need to create the file to keep the information. So database, you need to create the file. The Microsoft Word, to save the data, you need to create the file. Anyway, you need to create a file. That means it needs additional the system, the code. It's the overhead. So like the mission critical system, not mission critical. It's if the speed is the matter of your application program, like the database system, you need the faster approach. At the time, you can use the low device, directly access the data and save it. And who is in charge of the structure of such a data? Your application program. So DBMS, for example, database software should know how to sort and how to organize such a data. Okay, so that is otherwise most of cases we can use the file system. Still, many of the big company or the big project system they use a low device approach for the application program.
So without formatting hard drive, how do we save data?
How do we save the data? So your application program specify the, for example, HDDV, HDD0, and the sector number and the bit by bit. You need to save the data. Okay, it's hard to make the program of your application, but benefit is the speed. Okay, so that's the difference. It's the same thing. When you develop the file system, you should be able to read and write the raw device. You should be able to format your file, the raw device, right? So at that time, you can use the system code to format your data. Okay? But format does not mean you store the entire data. Instead, you can assign from here address 0 to 10 is the one block and so on. Okay? Then manage the system information. Okay, so in case, so we are going to focus on such a file system-based organization. So we can create it. This is a physical hard disk drive. Disk 1, disk 2, disk 3. However, your partition, or in other words, the volume is a logical level. So when you create the file system using your file system using the file system software like the NTFS or the UFS, the TFS, or the nowadays the EX1, 0, 1, 2, something like that. That software will create the partition or volume. Okay, this is a logical concept. Like the C drive, D drive, E drive, F drive. So you can create as many the drive, even though you have the one physical hard disk drive. Okay, then each file system, file partition has the directory information. That is the based on the basic file, directory, and the disk, the structure. So we have seen such a many. Even I do not know the whole the special file system. This is an example of the used in the Solaris. It has some temporary file system as well as the older file system. But in general, you are familiar with the general purpose of file system, UFS, the Universal File System, or the GFS, or the NFS is another file system for what? Network-based file system. So you can remotely connect the hard disk drive or disk drive remotely using the benefit of the network. Okay, so that is called the NFS. Even Windows provide NFS, the network file system. So you don't have to worry about whether this is local or but slightly different approach in case the network is a fail. How can we manage such a failure, recover such a stuff? But anyway, that is the file system. Some of the operating system use a different file system for the kernel space because that is the most important part. So they and also access a lot. They try to use the very fast media hard disk drive and the specialized file system. I do not know exactly what's the difference, but in each the operating system uses a bunch of different file system. Okay, then we will discuss more in details in the directory structure. Okay. So benefit, what will be the benefit of using the directory structure? It's very hard. Wow. It's the first time this year. Because I usually dress up because, do you know why? It's easy to select shirts and the pants. I don't have to worry about the mess. Really, it's a convenient. If I had the ironed dress shirt and the cover of pants, it's easy to pick up. And also today I have the faculty interview. So, and also sometimes most of the time I dress up in my class. I'm not going to church every Sunday, but when you go to the church or depending on the religion, so you probably dress up the best. So sometimes I answer just to show up the pedagogical philosophy. I dress up when I enter the classroom like when I enter the church. Don't believe? Anyway, but anyway, this is the simplest way to the dress up, really. But my wife will complain. She needs to iron this one. Okay, so what is the benefit of the directory organization? So what is the benefit? Easy to manage, okay? And also that easiness can make the efficiency. When you search the file, think about the 1 million of files in one directory for one area. It takes a time even to find the file. However, if you classify, if you organize a file by group or the name, so it can be easier, also it will be faster. That is the idea of the directory organization. So also naming, another one. So I can, for example, think about your folder. I can create the same name of the file in different folder. What about if you are using one? Anyway, even though name is not the major identifier of your file, but to recognize with your eye should be different. So most of the operating file system does not allow the duplicate name in the same directory. Okay, even though identifier are different. So identifier means it's a file descriptor, number for each file, but they do not allow the same name. Why? Because it's hard to recognize. You can use the file size or the last date, or you can open that to see. But anyway, the most of the file system does not allow. However, if you are using the directory, it's a different room. So we can easily address such a problem of the naming. Okay. Grouping is the same thing as if you are organizing your stuff in the, so you do better keep the same file, same information behind the class, so same thing, so grouping. So we can do the same thing using the directory or folder approach. So this is the simplest approach for the directory. So we have the single level directory. Okay. that this is a directory. What is a cat directory? This directory has all the header info, meta information of the file under this directory, okay, and so on. Okay, the benefit, so you can classify. Also, you can address the problem of the naming, same name of the file, by putting different directory, but still has the naming problem in case in the same directory and so on. What if I have the two test files with the same name? So you cannot address the still. Also, grouping, so it's limited by the one level group. So how can we address? So we can have the multi-level. So it's a naive way whenever we encounter such a problem, just like the when you learn the indexing structure in the database, so we can make a single level index. What if the single level index is slow? We have a multi-level index, right? So similarly, we can have the two level directory. So we can use, for example, the first level as a user. Okay, and each user has the same name, data. So we test it. So we can solve the problem of the naming. Okay, but the problem is how can we find the specific file? So this file location. So to address that one, we need to consider path name. Not only just the file name, we need to know the list of the directory which is called the path name. So using the path that we can find. Sometimes because of that, when you are using the Unix-based command line interface, you don't know where you are, right? So at that time, you can use the pwd command. So from time to time, so that is the reason PWD is one of the most popular used command for the Linux or the Unix user. PWD to check whether you are. Okay. So benefit, so we can have the same category, same directory name, same file name, but a different user. Okay. But problem, still, I'd like to see the old test file. But test file here. So it's not really good. It's a separate. For example, the data is here. So what if this user access the whole file of the data, access this one, but to access the another user directory with the path. You should know all the path. Also, you need to get the permission of the file. So the grouping is a problem in this two-level directory. How can we address? We can generalize. So it is a tree-structured directory. What is a tree? It's a data structure. So you get used. So what kind of data structure? What is the different from? What is a similar one? What is a similar data structure as the tree? Graph. So what is the difference? Graph is, which one is general? Graph or the tree? Graph is general. So let's take a look at the graph first. Graph, nowadays graph structure is very important, right? Why? Are you using Facebook? There are a couple of students who raised it here. Yeah? I can ask them, but today I cannot find. Probably somewhere. Right? So, because you are closest. I'm standing here. Anyway, so are you using Facebook? Yes. So Facebook, how can the Facebook company store the data? They need a data structure. Then what kind of data structure can keep the? You need to understand Facebook structure first. Facebook has the user, Facebook user. Then when you create your user, okay, what's going on? Nothing. Okay? It's just the pop-up. So they keep suggesting. Make the friend. Okay, that's the key point. That's the most the different thing from the other internet environment, like blog or other. So you can connect with the other. So that connection is the most important part of the Facebook or other social media. Think about the other social media site. Twitter has such a connection, relationship, right? Flickr also your favorite or group, community group. What else? The messenger is even that is not open, but if you have the connection or the friendship, you can communicate with them. So social connection is not easy to represent using traditional data structure such as the relational database model. Relational database model, you'd like to find the tuple that all of them have the same structure, column. What about the friend? It's different. So how can we represent? At the time, we can use graph. Graph consists of what? I think you are here. Graph has what? So you have me. So graph has node and edges, as you know. What is a node? It's a set of nodes. You have many entities. Like the entity in relational model is the same thing, but it has a different relationship. So if two nodes are related or connected or anything, we can create the edges. You have the number of edges. That's the same as the Facebook or other social media data structure. So easy to represent such a thing using graph. Okay. What about tree? Tree is similar. Tree has a node and it has the edges, but edges is a little bit different. It has parents and children, the relationship. One node may have many children nodes. It has a direction. You cannot change it. Unlike the graph. Graph does not have such a direction. But some of the graph has direction. Like the Facebook, Twitter, for example. Twitter, so you can follow me. Okay? Then you are follower and follow me. Right? It's a direction. When you can retweet the tweet, it's one direction. Unlike that, the Facebook friendship is there's no direction. Once you approve your friendship request, it's the same thing. So tree is different from the graph structure. So it has the parents and children relationship. Also regarding to the node, root node, there exists a root node, top of the tree, nothing in there. No parents node. Similarly, the leaf node does not have the children node. That is the tree structure. So we can adapt to such an idea of the tree to represent the generalized the tree directory structure, which means that each directory can represent the node. Okay? And node, and they are related by the subdirectory structure. So this is the subdirectory of the main. So parents and children relationship. Then this one, tree-based directory is kind of generalized. The two-level structure, it can be many levels. Okay? The most of the directory structure used in the modern operating system actually utilizes such a tree structure. Okay? Benefit is a generalized, so we can have the specialized as much as possible. Problem, still, it has a problem of the grouping, right? To read the data in other directory, you need to use the full path of it. Okay? How can you address that problem? We can make the, what about the Windows? Think about Windows, you already use. So for example, when I try to find all the directory here, for example here, what about this one? Is it located in this desktop? No. To access the file, Adobe Reader is an Acrobat Reader. I need to go to the C, under C, user, program, x86, something like that, finally Adobe. So I need to find that full path. Instead, I can create shortcut, right? So that is the generalized way to address the problem of the tree, to access from current location to access such a file. So why don't we make the link? Okay, in general, it's called the link. Okay? So to create, so we can generalize. Okay, so this is the first tree structure. So it has a grouping capability. How can we find the location? We need to have the full path of the file. Okay. However, what if even here we access, here to access, we allow many pairs. So it's a more enhanced tree structure. It's called a cyclic graph. It's no more at the tree structure. It's going to be graph structure. But in the graph structure, but it has a direction, so it's called a cyclic graph. But before that, to manage the tree structure, everybody knows such a data structure like absolute path or relative path. Absolute path means from the root we can specify all of them. Relative path is dot means current always. Two dot means the parent. Okay, that is the relative. No matter where you are, the dot means current. Two dot means the, for example, it's the same thing in the Windows. You know what is the password of this one? OS. So when you download this file, you can download this file from the textbook website. Okay, and the password is the OS. I don't know why it's not. So, for example, when I press the part 6 D.C, this is the current directory. LS. It's the LS current directory. But if you want to list of the file, the parents, you can do that. And it's the parents, no matter where you are. So if you are not sure where you are, you can type the PWD. This is the absolute path. This concept is used every file system that are based on the such a circular graph structure. Okay. Why this one is everybody understands such a concept? Why this one is important? For example, if you are developing something interface for your application, you can adapt such an idea to browse your data. You cannot always implement the interface as the graphical user interface. So you can use sometimes such a command line interface. How can I browse my file? At the time, you can use the idea of a file system. Okay? So you will use a lot of such a concept in your application program. Okay? Some students say, am I going to use the algorithm when I develop the operating system? Sometimes not, sometimes yes, but mostly not. But the knowledge will be used for some application program that are based on such a operating system algorithm.
So did you say that tree structure cannot group?
To how to make the group of this one? You need to actually going up and down, going up and down. Physically, it cannot. Physically, it's not group. But if you allow the cyclic graph, then you can make the link like that. Then you can count can be grouped. Here you can see the count of this. here you can see the count of it. So you can make the group. Problem. It may cause the problem of cycle. Okay? That is the reason it's a cyclic graph. There is no cycle. So this one refer this one, sometimes this one, the refer directory can be also the link. So it can be cycle. Cycle causes serious problem. You don't know who is the parent, who is the parent. So you can avoid such a cycle using the only a cyclic graph. Another problem is, what if from here on the step, on the count, you have the file, you delete the file. Okay? However, from on the dictionary at DICT, the count is still should be existing. But because this file is deleted from here, actually physically you cannot see the file from another. So that is the problem of the dangling problem. So it's a frequently it's a dangling pointer. When you allow such a cyclic graph, in case this one is deleted, but still supposed to be here on the count of the dictionary. Then how can you address that problem? There are several ways. Okay, each file should have the back pointer that point out who is the parent. So when you delete the file, you need to check the how many. So this file you can delete only one. So under W7 you can delete it. In this case, if you delete the file under spell count, you need, if there exists another the parent, you cannot delete it. Or you need to inform to the user whether you are going to delete this one. And also you can hold the count. So until this one is 1, you cannot delete. Something like that. That is the. What about the Windows? Windows use, as you can see from the desktop, it has shortcut, right? What about the Linux and Windows, the Linux and Unix system? How does the Linux system implement such a cyclic graph? You cannot create the file from the exactly same time from two parents, right? Doesn't make sense. Anyway, you can create the file under one directory structure. Then, how can you make the file? A cyclic graph file. This one. That is the link command, or sometimes ls. You can actually create after you create this file, you can create this link, like the shortcut. However, the link in the shortcut in the Windows is different from the Linux system. What is the main difference? Linux has the two types of the link. Two types. One is soft, another one is a hard link. Soft means soft. Hard means hard. Soft means it's physically only one file. When you create the link, okay? Physically, so one is just a link. Then create any back pointer or counter. Okay? So that is a soft link. In this case, if you update this one, automatically it's applied. Okay? So this is called soft link. When you create a soft link in the Unix, you can use the -s option. What about the hard link? Hard link means when you create the hard link, this file is created. Then, if you create the hard link, you can copy exactly same file, copy, and on the count. Physically two files, but they should be synchronized. When one of them is updated, this one is automatically updated. Double times double IOs are required. So this is the hard link. So it's frequently used in Unix and Linux system to implement a cyclic directory. You can practice. So I think that I upload the basic operating system command, okay, for your volunteer, for your exercise lab in the Canvas. So please do not ignore them. So you can practice by yourself. So you can find the Unix, the basic command exercise lab. Why don't you practice? Definitely, that will be very, very helpful. I realize that nowadays many of the students do not have experience of working on the Unix or Linux system, but you should have. So this is a link used in the. Actually, I don't want to write anything in the middle because it will be messed up. Today is the best one. So there are two types of link. One is the soft link and hard link. Okay. So this is a general directory structure. Okay. So you can see that this kind of thing. So that may cause the problem. So you should be careful when you make the link like this. It may cause the circle. Some of the operating system, file system allow such a circle, but mostly not. Okay, you should be careful. What if we have such a problem of the dangling pointer or some cyclic pointer? So file system has the garbage collection to for example, in case the dangling pointer like this one, this is supposed to be deleted, but here remain some dangling pointer, then you can remove using the garbage collector. You have seen the garbage collector in compiler also, right?
Yeah.
What is a garbage collector in compiler?
Object, if there's things like, let's say in Java, if the object is without a reference or point reference to that.
That's the example of the Java.
Yeah.
So Java, you can explicitly run the garbage collector where mostly the GC is running automatically. Well, then, what is the in general garbage collector? In the process, in your process, it's not always the permanent data. Global data, yes, you need, but many of them are temporary data. It's just a link, okay? And the heap or the stack is a temporary space. So, but if some of the data are not used, okay, then it's logically there is no chance to use. Then it's occupied in your process space. Then at the time, garbage collector check address by address, whether this is needed or not. If yes, there is needed, keep it. Otherwise, it will be free space of your process. That is a garbage collector. Okay. So, but I realized I'm not very good programmer. Even my programming skill is worse than you guys. You guys are much better than me. But many of the developers, I realized that do not have the concept of the garbage collector. So the reason is that nowadays most of the modern program languages, they learn the automatic garbage collector. But from time to time, you need to intentionally, on purpose, code such a garbage collector for better performance. The reason is that anyway, you have limited memory space. All your program, anything should be running on the memory. But because of the limited space, it will be slower. It may cause a lot of page fault. So because of page fault, your overall system performance degrades. At the time, you should be able to handle such a garbage collector. Instead of changing your algorithm, sometimes your overall application performance will be very good by just running the garbage collector. Not always you need to run. Why? Because garbage collector require a lot of resource also. From time to time, the optimized time. The most of Java provide optimize, but optimize does not mean it's the best perfect one. So depending on your application, so you should be able to learn the such garbage collector. It's a similar thing in the file structure.
So the
yes.
dangling pointer and the cyclic counter, they are same thing or different?
which one? The acyclic?
Yeah,
Acyclic, this point, the
same direction.
same thing, what same thing means what?
I mean, you said that's a landing pointer, right?
In case, so this one is the you remove RM, the file, slash space, slash count, and file name. But if you do not manage the who is the parent, in this directory has the header information of this file, right? So that is a dangling pointer. So at the time you can if you manage the back pointer, which means this file has the who is the directory parents. Then, in case this will be deleted, check whether this one is okay. You can ask the prompt. This one is linked from the here. You wanna delete? If yes, you can even delete the header information over here. Otherwise, you need to run the garbage collector. Check from time to time whether there exists the pointer, the file information, but it's not existing. Okay. The next one is the mounting to when you manage the, so we have learning the three main part of the file system. One is the file structure, directory structure, this could the structure. Then another thing is